All right, so in this video, we're going to find all real zeros and all complex zeros for a variety of polynomials, okay? We're going to use factoring, we're going to use quadratic formula, we're going to use the rational zeros theorem to help us find all those zeros, okay? We're also going to use the concept of multiplicity to help us out, and we're going to completely factor the polynomials using all those topics or concepts I just talked about, okay? So we've got a third degree polynomial here, 4 terms, okay? Hopefully you recognize that we can factor this one by grouping. So we don't have to go through the process of using the rational zeros theorem here because we can factor by grouping. So let's do that first. Also understand we've got a third degree function, so we're going to have 3 total zeros. Some may be real, some may be complex. We're probably going to have a combination of those 2 types. All right, so I'm going to group the first 2 terms and the last 2 terms together, okay? I'm going to take out a greatest common factor of x squared from this binomial, which leaves me with x minus 3, okay? Remember, when we factor by grouping, we want that binomial to match up, and that happens here. So the factorization here for now is going to be x squared plus 1 times x minus 3, okay? So what I want to do is I'm going to use the zero product property to find the real and complex zeros based on these 2 factors, all right? So let's start with x squared plus 1 here. I'm not going to have real zeros there because I'm going to end up with x squared equal to a negative 1, okay? So when I take the square root of both sides, I get plus or minus I. So these are going to be 2 complex zeros for this polynomial function, okay? Plus I, or positive I, and negative I, okay? We've got a really easy zero to find here. We've got x minus 3, so our zero there is going to be positive 3. That's obviously a real zero. So for this polynomial, we've got 1 real zero, which we can use that to graph the function, if you think back to what we've done previously. And we've got these 2 complex zeros, which don't help us when it comes to graphing, okay? So the zeros in order are going to be 3, positive I, and negative I, okay? And now that I know those zeros, I can write out the complete factorization using those zeros, okay? This would be 1 factorization, but using the zeros, I can rewrite those factors as x minus 3, so it's x minus this 0, x minus I, so x minus this 0, and x plus I, so x minus a negative I, which becomes x plus I. So this would be the complete factorization using the zeros, all right? Let's take a chance on example 2, then come back and check your work. All right, so for number 2 here, we've got a trinomial here, a third degree trinomial. We're going to find all the zeros, both real and complex, and we're going to use those to write a complete factorization of the polynomial, okay? So in looking at this trinomial, I can tell right away there's no way for me to factor this any other way. So I've got to use the RZT here to find my possible zeros and then use synthetic division to find which one is a real zero, okay? We're going to have 3 total zeros because we do have a third degree function, okay? So we're going to use the rational zeros theorem here. Remember, we're going to divide the factors of the constant, which in this case are 4, by the factors of the leading coefficient, which is 1. So the possibilities for zeros are plus or minus 1, 2, and 4. Okay, so we got 6 possibilities. Because we've gone over that in previous sections, I'm not going to walk you through the entire process. I'm going to go ahead and tell you that negative 2 is a 0, and therefore x plus 2 is a factor. Okay, so let's go ahead and show the synthetic division because we're going to need that to find what we get when we factor x plus 2 out of this. Okay, so I'm not going to talk all the way through this. Okay, you know how to do synthetic division. So my first factor is x plus 2. And my second factor is going to be the trinomial x squared minus 2x plus 2. X squared minus 2x plus 2. Okay. If you've forgotten any of this, you're going to want to go back and rewatch some of those videos or ask questions in class. All right. So again, we know the first zero is negative 2, so I'm not going to waste a whole lot of time here. Okay. For this second one, though, this trinomial here, I'm going to have to use the quadratic formula to solve that. Okay. So my b value is negative 2. B value again, negative 2, minus 4 times A, which is 1, times C, which is 2, over 2 times A. Okay, so we just plug everything in for our quadratic formula. I'm going to clean up the discriminant here, what's underneath the radical. That gives me 4 minus 8, which is negative 4. Okay, and the square root of negative 4 we know to be plus or minus 2i. Okay, now everything has a coefficient of 2 here, or is divisible by 2, so I'm going to just divide those out. So my zeros, complex in this case, are 1 plus I and 1 minus I. Okay, remember we said we were going to have 3 zeros. We have 1 real zero, and we have 2 complex zeros. So they are negative 2, 1 plus I, and 1 minus I. Okay, now we want to do a complete factorization using our zeros here. So x minus a negative 2. Remember, we're going to subtract the zeros to create that factor. The second one is going to be x minus this 0, 1 plus I. Be careful. Notice when I need parentheses there to keep my sign straight. And then it's going to be x minus 1 minus I. Okay? So we're just going to distribute this negative 1 in both of these. So x plus 2 is not going to change. Here I'm distributing a negative 1. I get x minus 1 and then minus I. And then over here I'm distributing a negative 1 again. And I get x minus 1, and then I've got minus a negative I, which is a positive. Okay? So this would be the complete factorization for number 2. All right? Give number 3 a try, and then come back and check. All right, and finally here for number 3, we're going to find all the zeros, both real and complex. Okay, in the first couple, I haven't gone over this last part. If the multiplicity is greater than 1, you want to state that. This one's going to have some zeros with a multiplicity greater than 1, so just be aware of that as you try this one. Okay, we've got a polynomial that can be factored with a GCF, okay? And then maybe there's something else left in there that we can factor. We'll just have to see. And I'm telling you in advance, what remains can be solved without using the RZT, okay? We've got a 5th degree polynomial, which means 5 total zeros. Okay, so you want to keep that in mind as you find these zeros. All right? So we got a GCF. These are all divisible by 3x, so we want to take that out. And the trinomial that's left inside is x to the 4th plus 8x squared plus 16, okay? Hopefully you recognize this as a perfect square trinomial, okay? So this one can be factored. Otherwise, it's going to take a little bit of work trying to factor that another way. All right, so that leaves us with 3x as my first factor. And then when I factor that, I get x squared plus 4 to the 2nd power, okay? So remember that x squared plus 4 to the 2nd power is equivalent to this trinomial, okay? If you can't factor that, this one's going to be a much harder problem. All right. So, again, first 0, I know we're going to set that equal to 0. So my first 0 is 0, okay? So this graph, if you want to think about the graph, would cross both the x and y axes at the origin, okay? X squared plus 4, we want to set this equal to 0. Okay, we've got a pretty easy solution here. X squared equals negative 4. Take the square root of both sides. So x equals plus or minus 2i. So at this point, all you're seeing is 3 zeros, 1 real and 2 complex. But notice this factor, x squared plus 4, occurs 2 different times. So what makes that factor 0 is going to have to occur 2 different times. So both of those zeros are going to have a multiplicity of 2. It's important to keep that in mind. All right, so my zeros then are 0, positive 2i, and negative 2i. All right, this one only occurs once. These two both occur twice, so that gives me 5 total zeros. And then the complete factorization, again, 3x, we can't forget the 3. 3x, x minus 2i, again, that occurs twice, so I need to make sure that factor is squared. And then x plus 2i, or x minus a negative 2i, which I would rewrite as x plus 2i to the 2nd power, okay? So that's how you find all the real and complex zeros of different polynomials.